So all of you listen, we'll study one topic here, effect of frequency of incident radiation on stopping potential. So frequency, how it is affecting stopping potential, that one we'll see. Now see here, y-axis what graph you are taking? Y-axis you are taking photocurrent. Y-axis what? Photocurrent. And x-axis what you are taking? Collector plate potential. Collector plate potential. Positive x-axis, positive potential. Negative x-axis, negative potential, that is retarding potential. What potential ma? Retarding potential. Now see here, your intensity is constant. Your intensity kept constant. So intensity I is constant. I is constant. But remember, frequency different. Frequency is different. Constant, this is constant. Intensity constant, but frequency different. So different frequencies you are taken. Okay. So now listen. See, for different frequency, we are getting only one saturation current here. What we are getting? One saturation current. Different frequency, what we are getting? One saturation current. For different frequency, we are getting one saturation current. But remember, for different frequency, we are getting different potential, stopping potential. See here, your frequencies are taken like this. What frequencies are taken? Now frequencies are taken nu 1. See here, nu 1, nu 2, nu 1, nu 2, nu 3. Nu 1, nu 2, nu 3, right? So your nu 3 greater than nu 2 greater than nu 1. For different frequency, you are coming what graph? Na? Different stopping potential coming. V minus V01 minus V02 minus V01 minus V02 minus V03. Now, but remember, for all the frequencies, you are getting only one saturation current here. All the frequencies, what you are getting? Only one saturation current. Yes or no? So that means frequency does not depend on, or saturation current does not depend on frequency. Like that you can tell. For all the frequencies, only saturation current is constant. Okay. If intensity is constant, so intensity remains constant, na saturation current remains constant. Okay. Now for different frequencies, your different stopping potential. So this is what you are getting the point here. All of you listen. So now, in terms of wavelength also you can write. Suppose I am telling like this. All of you listen. All of you listen carefully. Suppose I am saying this graph is like this one. Graph is like this. Graph is like this. Here are for collector potential, photocurrent. Now graph is like this. Graph is like this. Graph is like this. Now listen. Here you have lambda 3. Here lambda 2. Here lambda 1. Yes or no? Now you know frequency is inverse proportional to lambda. Then what will happen here? Now here lambda 3 will be less than lambda 2. That will be less than what? Lambda 1. Understood? So in terms of lambda if you given, you no need to worry. So as frequency is inverse proportional to lambda, here is nu 3 greater than nu 2, nu 2 greater than nu 1. It is coming now. Here what you do? Now here you change. Here lambda 3 less than lambda 2 less than lambda 1. Suppose I am saying this type of one graph came in exam. So this type of graph one came in exam. Now here this is the photocurrent and stopping photocurrent and collector plate potential. Photocurrent and collector plate potential graph. Now here it is lambda 1, lambda 2. Tell me which lambda is greater? Lambda 2. See here. Here see lambda 1 which is near close to origin. Which graph close to origin, that lambda is greater. Are you getting or not? So here what will happen? Close to origin is lambda 2. So lambda 2 greater than lambda 1. Understood or not? but in terms of frequency it is different. Which is far, this nu 3 is far from the origin, so nu 3 will be greater. Nu 3 graph, are you getting or not? So please keep in mind, so your lambda 2 will be greater than lambda 1, are you getting or not? Actually in your book this diagram only given, this given, this graph, and this graph also 3 mark question comes. What is the question? Now draw, listen, question will be like this: draw the graph of photoelectric current versus collector plate potential, photoelectric current versus collector plate potential for same intensity different frequency, same intensity different frequency, are you getting or not? Same intensity and different frequency, that one we are telling also. What we are saying, that one we are saying intensity constant, okay. So this type of diagram will come, right? Try to understand. So your intensity is same or constant, intensity is same or constant, intensity is same or constant. Now intensity is same or constant, but frequency is different, frequency okay. So listen carefully, and if lambda 1 lambda 2 like they're asking, you can do this one. Clear? Now from this graph what conclusion we can draw? Let's see in the next page. Conclusion is the stopping potential is more negative for higher frequencies of incident radiation. So what we understood, if in nu 3 greater than nu 2, you see nu 3 corresponding to nu 3, whatever stopping potential is coming, that is more negative as compared to minus V naught 2, okay. So what happened here, that is what they are telling, stopping potential is more negative for higher frequencies of incident radiation. Second thing what they are telling, the greater the frequency of incident light, greater is the maximum kinetic energy. That means we are relating kinetic energy with frequency now of photoelectrons, kinetic energy of photoelectrons. Consequently, greater the retarding potential required to stop them completely. That means as frequency is more, that implies stopping potential becoming more negative stopping potential, and you know stopping potential related to kinetic energy already you understood, Kmax equal to EV naught. What you understood? Kmax equal to EV naught. That means they are linearly dependent. So that means definitely kinetic energy will depend on what? Kinetic energy will depend on frequency. Yes or no? So these all are basically experimental observation. And if a kinetic energy frequency graph will get one straight line graph because linear relation. But nobody was giving any equation for this. Okay, how it is coming? Kinetic energy linear proportional. That one we'll see in the next graph. We'll see. Einstein gave proper equation and explained correctly. Okay, so from that one we'll see. So first what you do, now here this graph you practice and remember. What is the graph? The effect of frequency of incident radiation on stopping potential. Okay, so from here you understood that stopping potential depends on what? Frequency. Stopping potential does not depend on intensity, because for the previous graph different intensity only one stopping potential, but here different frequency different stopping potential. Clear or not? But there is saturation current here will be same for all the frequencies. Okay, that one also remember. Clear? So please note it down. Note it down. Next page also, this language little note it down. Okay. Thank you.